Hi and welcome to the lesson about auto-scaling. And here we will see two different approaches to drive the scaling behavior. And, and one of the common approaches to measure when to scale a streaming pipeline is lag. Lag, which generally means how far your customers are from the producers. So if your producers are sending 10 records each time, 10 records per minute, and your customers can only consume 5 records per minute, you can already see that after 2 minutes they will be 10 records late regarding the real time. And of course, this lag will increase with time. And the lag action is like that. So first, to start, everything runs smoothly. Our producer sends 3 records every time. Our customer max throughput is 3 records. We fine-tuned it and the lag is 0. But with time, the customer throughput goes down. Maybe we added some extra transformation, required network traffic. Maybe we used a new library that had some performance issues. Nonetheless, the consumer throughput decreased, and you can see that we have now a lag of 1 record. And the record-based definition is a bit simplistic because often we reason about lag in terms of time. So how late I am, how many minutes, seconds, or hopefully not hours or days I am regarding the data that is available in my input partitions. And here we have data for 10 o'clock already in our partitions, but the customer is only processing data for 9:50 or 9:52. And the lag is defined as the max function from the difference between the last available event in each partition and the event time of the processed row in the corresponding customer. So here you can see that the max for that is 12 minutes, meaning that our consumers are 12 minutes late regarding the data generation time of the producers. And to reduce the lag, you can apply 2 solutions I detailed in the previous lesson. So the work stealing, when you add more compute to process the same input, it can be very good to handle unbalanced partitions. Or you can also scale data source, add new partitions, and correspondingly add new consumers, again to better distribute the workload. But this lag is not the single metric you can use in auto-scaling to trigger the scaling action. Another one is the hardware. And the hardware metrics are still accurate in streaming pipelines, even though they are somehow decorrelated from the streaming and time-based processing. And to understand it better, let's summarize different auto-scaling metrics. So we have some time-based, like data progress, some job like the throughput, which is also related to time, because you can see there is a division between the number of records per second, and there is also the hardware. And even though the hardware doesn't sound like streaming, it can also contribute in making your pipeline much better, because you can reduce the memory pressure, you can reduce the CPU pressure, and by doing that you can have better parallelism either for writing or processing, and this better parallelism will obviously impact other measures like the throughput, because you will maybe finish each task earlier and take your input data earlier, or Kafka lag for exactly the same reason. So remember that even though streaming is a lot about time, I think you understood it when I was presenting the difference between event time and processing time. The hardware metrics are still accurate here, because after all, your processing runs on top of clusters, and you want your clusters to be efficiently used, and this efficiency will of course impact the processing time, so it will also impact the overall latency. And that was my closing sentence. Thanks for watching and see you in the next lesson.